Hi everyone, welcome back to the thermochemistry problem solving part. Okay, so let's look at this question. This question, we already have this equation, okay? And this equation has the associated enthalpy or heat, which is a negative 1078 kilojoule. Okay, the question is asking for how much energy is released by this reaction during the formation of that much gram of the nitrogen gas. Okay, so let's think about this question. You probably need to think about this question into two steps. Okay, first we need to convert. Okay, we need to convert the mass of the nitrogen, which is here is 140 gram into the mole of the mole of the nitrogen. Okay, because all the questions, stoichiometry question in the chemical reactions is based on the mole, not the gram. So you need to convert the mass to the gram. Then the next steps, you're based on the stoichiometry and you'll figure out what is the enthalpy, the change of the enthalpy based on the mole of the nitrogen we have. Okay, so here the conversion factor you are looking for from the mass to mole is the molar mass. And from the mole to the enthalpy, the change of the enthalpy, then that's going to be the stoichiometry. So here we already know that's a 3 mole. If we have a 3 mole of the nitrogen, we can produce that much of the heat, kilojoule. Okay, so this is the connection between the mole of the nitrogen and the heat. Okay, so that's a 3 mole of the nitrogen can produce negative 1078 kilojoule of the heat or the enthalpy. Okay, so let me use another pen. We can set up a long equation to solve this problem. First, we write down what we have. Okay, what's the question given? Which is 140 gram of the nitrogen. Okay, then the first step is we need to convert the gram of the nitrogen to the mole of the nitrogen. Okay, so we put the gram of the nitrogen on the top, bottom, and we're looking for the mole of the nitrogen. The relationship between is the molar mass. We know 1 mole of the nitrogen is equal to 14 times 2 gram of the nitrogen. Okay, so after this step, we can figure out the mole of the nitrogen. Okay, and the next step is once we know the mole of the nitrogen, we need to figure out what is the change of the enthalpy based on that. So we already have the conversion factor. So we put the mole of the nitrogen in the bottom and put the kilojoule on the top. The bottom is what we need to cancel out. On the top of the fraction is what we need. Okay, we need the kilojoule, the heat, the enthalpy. Okay, so we have a 3 mole of the nitrogen can produce 1078 kilojoule of the heat. Okay, and then based on the equation, we can see the gram of the nitrogen and the gram of the nitrogen are cancelled. Mole of the nitrogen and mole of the nitrogen are cancelled. The unit are left is kilojoule, which is what we need, right? This is heat. Okay, so then we put everything into the calculator. 140 times 1078 negative divided by parenthesis 14 times 2 times 3 parenthesis. Okay, so when you do your calculation, please don't forget that has a parenthesis. In the bottom part, you need to have a parenthesis to cover it. Otherwise, you're gonna have a problem. That is equal to negative 1796.6.7. 1796.7 negative 1 is a 1796.7 796.7 kilojoule. Okay, and then let's look at the sig fig. The question has this is a 3 sig fig, which is the question given. So the final is a 3 sig fig. So we keep this, and this. It's gonna be, and this one is round up. So it's 1.80 times 10 to the 3 kilojoule. Okay, and this is the energy. Okay, it's going to be released. And the final answer is we have a 1.80 times 10 to the third kilojoule of the energy are released. Is released. Okay, it's talking about release, so it's already including the negative sign. So you don't have to write the negative sign here. Okay, so this is the answer. 1.8 times 10 to the third kilojoule is released. I hope you got it right. Okay. Thank you for watching it. Bye. See you later.